Sometimes I get mixed up as to what we've covered and when we've covered it, and we'll cover stuff with E later on next semester. We haven't covered it yet. And so I thought I'd change things a little bit. I didn't want some of the details to be a big distraction for you. So if you guys would take a minute, look at your example 6, make a couple of the necessary edits there, please, and make yours look like mine. Okay? And we'll work on this one together. You will definitely want your calculator active on this one, so if you don't have your calculator out, get that out at some point as well. Sorry, I'll move this. There's going to be some pretty intricate calculator steps here, so while I'm making a video of this, if you want to do best pay attention, you can always go back and watch the video later if you wanted to. Okay, so it says position of the particle moving along a line is given by S of t, and you got S of t right there for the interval open on 0, open on pi. This particle speeding up or slowing down the third time, the speed is 3. You know what? I'm going to make this simpler for you. Can I make one more edit? I'm just thinking about this. I want to make this super simple for you. Instead of saying the third time speed is 3, let's do this. Let's just say the first time. Again, I don't want the details to be a big distraction. The reason why I did this, I really wanted to loop back and give you some spiral review with some older topics too. Hopefully this goes. We'll see. Okay, so says is the particle speeding up or slowing down? The first time speed is 3. What is our first big unknown? We're trying to figure out is speed increasing or decreasing, but what might we need to know before we start working on that? Come on, pick this apart. What's that? Critical numbers. So nothing. Okay, so let's take a further step back. Critical numbers are going to come into play, perhaps with mins and maxes. And the increasing, decreasing, sometimes they do come into play. But I want you to think back to the couple of statements that I made right above this. And then what I just did with my whole little demo up here. I told you that speed would be increasing when velocity and acceleration have the same sign. Speed would be decreasing if acceleration and velocity have different signs. Does that make sense? And so instead of jumping to critical numbers, which are a thing, and obviously we use those a lot, let's base our thoughts on those concepts. What might I need to do? Why would I take the derivative of that? Get velocity. That might be an intelligent first step. Let's think about that. So if I was going to actually do that, and I think that is a good idea, what process would I have to use to find that? Yeah, quotient rule. You're right. Okay, so I'm going to work quietly up here. You guys, if you haven't already done so, work quietly there. Let's figure out what the velocity would be. Okay, you guys get something like what I did? That quotient rules? Give yourself plenty of room. We're not going to do a ton of detail work, but you want to leave. Notice how I've left myself a lot of room. I didn't start writing right in the middle of the space there. Always start at the top, right? Yeah. Okay, so I think Dax's idea of like, hey, I know velocity is going to play into this. So let's figure out a velocity function. I think that's pretty smart. So then let's go back to the basic concept. Again, these are concept-based ideas. They're not just processing ideas. So that's why I asked why, and I thought your idea of why was good. Okay, so then what are we going to do with that? Plug what in? I'm not saying you're wrong. I just didn't hear you very well. I heard you say plug.
No.
Okay.
Should we plug in 3?
Okay, what kind of a thing is 3?
The time. Or speed.
3 is a speed, isn't it? That's where this one gets a little bit tricky. If I plugged a 3 and I would say, well, where do I plug it in? It'd be tempting to plug the 3 in for the t, right? But the 3 is a speed. It is not a time, so that wouldn't work. Robbie, what do you think?
Is it 3 for the t?
Really close. Really close.
Absolute.
I would say it again.
But it's absolute.
What is absolute?
The function.
And so this is where we go back to those earlier principles, because you probably read that off there, right? Speed is not the same as velocity all the time. Speed could always be represented by what Robbie said, the absolute value of velocity. So then what if I said this? Absolute value of velocity is speed. And yeah, you could say that that equals the absolute value of that whole thing on the right. I don't feel compelled to write all that out. Where is that? What's the time? Isn't the time kind of the issue here? We weren't given a time, but we were given a clue about how to find the time. The first time, something has to be bigger than something?
It just has to be bigger than 0.
What has to be bigger than 0? Sure, time has to be between 0 and pi, right?
It's different on here. Sorry.
Time has to be between 0 and pi. Need you guys to process this, think this through. Dak said, hey, let's find a velocity function. Great. Robbie said, maybe we should think about a speed function. I say, also great. What are we going to do with it? What do you think?
You're going to have to derive it again.
Because you want acceleration?
Yeah.
We'll deal with that later. Let's figure out, because isn't this time the issue? Because they're all like, if we just knew that it was t equals 2 or something like that, wouldn't we be good? We could have this over with pretty quick, but we don't know the time. You see the word time up there? The first time. So we've got to figure out something about time. Yes?
Do we set that equation equal to 0?
Set what equation equal to 0?
V of t does that.
So I want to be clear. You're saying, do I do this?
Oh man, no, the absolute value.
Okay. Why? So this then.
Yes.
Why do you say that? Just because I ask why doesn't mean that you are wrong. I just want to know if you
I
know.
don't know why.
A blind squirrel finds a nut every now and then, right? A stopped clock is right twice a day, right? I just want to make sure that you're not like that stopped clock that just happened to be right this time, right? That's why I'm asking why. I'm not saying you're wrong. Go ahead.
It says that it's asking like, oh, okay, well, is it speeding or slowing down the first time the speed is 3? So it says the speed is 3. So we said,
You're like literally interpreting it, aren't you?
yeah.
What does the word is almost always mean in math? Equals. So they're saying, hey, the time we care about is the first time, and then I like kind of the way Tim approached that. Speed is 3. Isn't that speed equals 3, like literally translated? It's well said. I think that's a nice strategy you took there. Okay, so now this guy's solving this equation. This is going to be our key to finding our time. We are not going to be doing this without the calculator. Grab your calculators, and let's see here. I'm gonna write a couple things down because I gotta do some monkey business with the screen here. So v of t equals sine of t times 6t squared minus 2t cubed times cosine of t. Oh yeah, we're definitely going to be graphing this. Okay, so I'm just going to write a little bit of this up on the board because when I switch screens, it makes me erase stuff. So there's my velocity function. Here's the equation that you guys came up with. This was a really good idea. So I'm going to try to solve that equation via the calculator. So here goes. I think you can say it however you want.
Really?
I think I'm going to say it however I want.
Via?
Okay, here we go.
Jake would slap me if I said via, if it was just me.
Can I give you guys, I want to help you be really efficient with your calculator. Let me give you a little bit of just some direction here. What I'm going to do for my y1 is I'm going to just put my velocity function, that top one right there. So I'm going to go, I'll go open parentheses because I know it's going to be the numerator of a fraction, sine of x times 6x squared minus 2x cubed cosine of t, or cosine of x, I guess, on the calculator. So that's my numerator right there. I'm putting the whole numerator in parentheses. Does that make sense? Because I'm about to divide by something. So divided by, it's going to be sine of t quantity squared, sine of x, double close the parentheses squared. I think I might be able to show you some cool things about your calculator that you maybe did or didn't know. I hope you know these, but if you don't, I'm going to show you some cool stuff. Okay, so that is my, what kind of function was that? Sorry? That's my velocity function. So
Can you
what?
put an absolute value in there?
So that is a massive pain, isn't it? So how about this? Check this out. I know I'm going to be working with velocity because I know that speed is increasing when velocity and acceleration are same sign. What if I did this? For my speed function, what if I pushed these buttons? Math, you can see them light up red when I push them, right? So math, I'm going to slide over to number. I'm going to use my absolute values here as suggested by Addie. So I'm going to go absolute value of y1. So to get y1, remember I go alpha, trace, and I choose y1. So right now the way I have this set up is y1 is my velocity function. y1 is my velocity function. y2 is my speed function. Yep. And let's get our way back around to this. We want to solve this equation. Speed equals 3. And so my y3 is going to be just 3. And in just a second, please, 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 whatever you do not jump the gun and just push graph right now. Don't. Please don't. It's going to be messy. Guys, hey, listen. I don't think any of you know this. Just looking around, maybe a couple of you do. Would it be fair to say that since I'm trying to solve speed equals 3, I want to graph y2, and I want to graph y3, but I do not really want to graph y1, do I? It's going to make it a mess. So here's how you do this. You slide the little mouse essentially over there to the equals. Do you see how the equals is blinking there? I don't want to turn that one off. I'm going to scroll up. I don't want to turn that one off. I do want to turn that one off. The way I turn it off is with the blinker on the equal sign, I just hit enter. And notice, if I get off of that with my little mouse there, you notice how y2 and y3 equal signs are lit up? They're highlighted, I guess, but the y1 is not. What that means is that when I hit graph here in a second, it's going to graph y2 and y3, but not graph y1. Well, y1's still there. We need it there, but we just don't want to graph it. Does that make sense? I'm trying to help you be efficient instead of like tangling this massive web of graphs and what do I do with them again? Let's be efficient. Okay, I'm going to make my window from 0 to pi. So I'm going to go window x min 0, x max, pi. I don't really know about my y mins. Maybe I'll just do like negative 5 to 5 or something like that. Y min, y max. And then I'm going to hit graph and see what happens. I just made plus minus 5, my y min, y max. I made 0 to pi my time interval just because that's the domain. Are you in radian mode or degree mode? 0 to pi on my x's. I'll go back to my window. So here's my window. 0 to pi for x, negative 5 to 5 for y. Oh, okay, so you're going to need to do it with bars, y bar function. You can download the new operating software that will use that stuff if you want. You can go to ti.com and just get a little code. You can like upload it all. It's pretty convenient. So how you guys doing? Jake, is this working better? Still thinking a little bit? Raise your hand, please. Let me know if maybe something's off with the craft or, I don't know. Yeah, Gretchen. Oh, sure. So you've got to use the old school button tables. So bars, variables, Y variables, function. Okay. Yeah. Might be catalog. It might be something like that. Catalog, you can't search the catalog very fast. Like you push so many buttons to get to it, it might be faster. There might be. I don't know about the 84. I know the 84 has a lot of videos and stuff like that. I don't know about the 83. You can tell how often I use that stuff. I have no clue where it is. If it exists or not. All right. Yes, ma'am. Hey guys, listen up, please. Ellie asked a great question. She said, can you explain again why we did the absolute values on VFT? Because VFT is velocity, and velocity is a vector. Whether velocity is positive or negative has a very specific meaning, right or left. Speed is simply the magnitude of velocity, so positivity or negativity doesn't matter. So we absolute value it to make them all positive. Just like the speedometer on your car, there's only positive numbers and zero. So speed is always just going to be simply the magnitude of velocity, meaning absolute value of it.
Okay.
Just basically the definition of speed.
Yep.
And the reason why we did that is because we said we want to find out what's going on the first time speed is 3. And so we had to set speed equal to 3 as opposed to velocity equal to 3. Okay. How you guys doing? Any questions? Okay, so let's solve this then on the graph. Hope you guys are comfortable with this. This is something you can definitely do. We're going to go second, calculate. I want the intersection point. So you're going to go second, calculate 5. And it wants to know what the first curve is. There's only 2 of them. There's the second curve. And I'm going to guess. Have you guys ever done this for your guess? Are you guys in the habit of like moving the little blinky thing around for your guess?
Yes.
Don't. Guess. I'm going to say 0.8. You can just type in your guess. It's a lot fewer button pushes. Just type in, like, do you see why I picked 0.8? Maybe 0.7. Intersection point looks that-ish. So I'm just going to say my guess is 0.8. Then I hit enter as normal. And
I've never used it on gas.
yeah. You can only do that. Well, no, you can do it on the, you guys know when you do like right bound, left bound? You can type in the right bound and the left bound. You can't type in first curve, second curve, right? Like the blinker will just be on one of the curves, and you say, yep, that's one of the curves. The blinker will be on the other one. You say, yep, and that's the other one. But then you can type in the guess. Definitely type in the guess. You guys getting the same? Right?
Wait, why do you need a calculator? Why do you need a calculator?
Because it asks you for it. If you don't, I don't know if you have to on this, because maybe there's only one intersection point in this window. I'm saying if you're going to supply a guess, you can type it, or you can move the cursor over, or you,
So, if you do guess, then you can kind of show like where it's
you're telling that, yeah, this works if there's like 5 intersection points, and you're like, I don't want this one, I want that one. You give it a guess that's closer to this one than that one.
Okay, I never knew that was why.
Yeah, because you could have like multiple intersection points. So, yeah, that's what it's for. Okay, so I got t is equal to 0.65085478. So can anybody tell me the significance of that number? That's the time at which the speed equals 3, and that's also the time that we want to find out is speed increasing or decreasing. Make sense? So we're gonna follow our concepts here. So let me get out of this screen real quick. I'm gonna go back over to here, and I'm gonna say more or less have what I need here. I'm gonna say absolute value of VFT was equal to 3 when t equals that 0.65085478. And this is where we can wrap this up. This might have taken a lot of effort to get to this point. This should finish fast as long as you know our concept. Speed will be increasing if what? Same sign. Acceleration and velocity have the same sign, but speed would be decreasing if acceleration and velocity. So all I have to do is really test out the signs of acceleration and velocity. The good news is I already have that velocity function in my calculator, so I need to figure out velocity at 0.65085478, and then I need to figure out acceleration at that same time. Velocity should be really straightforward because we already have a velocity function. I want to remind you of an easy way to handle the acceleration, okay? Let's take a minute on your calculators. You guys remember how to use, gosh, I don't know, maybe you do or don't. Do you guys remember how to use the fact that y1 is your velocity? Make this a super easy evaluation. Okay, let me show you. Here's what I would do if I were you. I would say, I'd clear out of this, and I would use my variables again. I would go alpha, trace, and I know my speed is in y1, right? So speed is in y1. Here's how you can evaluate y1. Are you watching? y1 parentheses 0.65085478. What that'll do is that'll take that 0.65 number, plug it in for the input for your y1 function. It'll do all that evaluation. Have you guys done this before?
Right.
Makes it super easy, right? There's no like, oh my gosh, I lost a parentheses or alpha trace.
Isn't it just going to be 3?
Nobody's ever taught me this stuff.
What's that?
So many things I've never been taught.
It's either going to be 3 or negative 3 because we absolute valued it, right?
Okay, I see.
Off the bat, we maybe don't know yet. We're going to find out. So, hey guys, listen up. Interestingly enough, this came out to be 3, more or less, right? That should hardly be a surprise, but you can't assume that it would have been 3 because it could have been negative 3, right? Remember we absolute valued to get our speed? It was either going to be a 3 or a negative 3.
Couldn't you tell from the graph that it was positive?
But that was the graph of speed, and everything on speed is positive, right? So it was either going to be a 3 or a negative 3. Had to be one of those two. Turns out it was a 3, right? So I'll write that up here. So I'm going to say velocity at 0.6508 is equal to positive 3. Okay. Let me just remind you this. I'll keep saying it. If you're going to figure out if speed is increasing or decreasing, we have to compare the signs of velocity and... How does acceleration relate to velocity? So I would really like to be able to differentiate my velocity function without having to go through another quotient rule. Why don't I just use Math 8? So check this out. Again, in the hopes of helping you be ultra efficient, I could just go Math 8, and I want to differentiate. I want to do ddx of which of those functions in my function list? The velocity, which I put in as y1, right? That makes sense? So I'm just going to go ddx of y1, and where do I want to evaluate this derivative? At the 0.65 number, yep. So this is taking the derivative of a velocity function, which will give me an acceleration function, 85478. And I got that. Did you guys get the same thing? So I would say acceleration at that 0.6508 equals 5.9225-ish. Okay, so here's where we would practice writing a conclusion. These two numbers are neat and everything. What's the most important thing about those two numbers? Yeah, they're both positive, and we want to be specific to our numbers. So I'm going to say they're both positive, both greater than 0. So my conclusion would look something like this. Because v of 0.651 maybe is positive, and a of the same number is also positive, my conclusion would be speed is increasing, right? They both have the same sign. Therefore, speed is increasing. Okay. So, can I give you guys full disclosure here? I think most of the questions dealing with the idea of is speed increasing or decreasing, most of them, the details will be quite a bit easier than this one. The way I worded it was saying, hey, the first time speed is 3 and all that stuff. That's a challenging aspect of this one. And so I feel like if you can start to get a handle on these details, you'll be okay. I mean, most of the time, I'd say a lot of the times, a little bit easier than this. Anyways, Tim.
So what does it mean if it says the third time speed equals 3?
Well, so that's a little bit of a result of me deciding I wanted to change my position function. So with that e of t, or e to the negative t, whatever that was, it's never 0, but our new denominator was a sign, right? And sign is 0, and you can't divide by 0, and so I had to limit my domain. Does that make sense? So we'd have to change our domain around to make it fit that. So anyways, that's all it really was. It was more of like a details thing that I had to make sure that we had straight. Okay, so guys, here's your big takeaway. Speed is increasing when? Say it out loud. Come on. Speed is increasing when? Speed is decreasing when? That's it. That's your big takeaway. The rest of it is mechanics of like, how do I figure out this? How do I figure out that? That's your big concept. That's the thing you try to take away. Any questions? Okay. Good deal. Let me get out of this screen and let's do a little bit of work in 3.4. By the way, key takeaways here. Like if you're a little 3x5 card, flashcard kind of a person, be some good stuff to have in there. It's basically 3.3 in a nutshell. All right, there's a bunch of good extra practice. Highly encourage you as you think about quizzes and tests in the future of working through those extra practices. Okay, so our intro video basically is taking things to the next level. I think it'd be fair to say that in section 3.3, everything was about the first derivative, right? So let's do a little review of that. You guys ready? See me finish my sentence. F is decreasing when f prime is negative. You guys get that? F is decreasing if f prime is negative. So listen. If we have a critical number, and at that critical number, f prime goes from positive to negative. What's happening? Relative maximum. Right. Right. If f is continuous and differentiable, then which theorem applies? Say again? Mean value theorem. That's right. Mean value theorem's conditions are continuity, differentiability. Okay. What happens if you have a critical number, but f prime does not change signs around that critical number? You have a min, max, or neither? Neither. Don't you have to have a sign change in f prime to get a min or a max? Okay. Guys, if f prime is positive, then f must be? If f prime is positive, f must be increased. It's true. If we have a critical number and f prime goes from negative to positive, then f has a relative minimum. So let me ask you one last question. If you're looking for absolute, maybe two more questions. If you're looking for absolute extrema, what are your candidates for absolute extrema? Endpoints and critical numbers. But what if you're looking for relative extrema? What are your candidates? Only critical numbers. So do you see how as we've kind of built this out a little bit, you see how it gets a little more tangled and a little more tangled? Well, today and Monday, or for you guys Tuesday, it's going to get just a little bit more tangled, and then that'll be it for the tangling. By tangled, I mean we're going to introduce one more level of thinking to this. So 3.3 is all about, what does the first derivative tell us about stuff? This one's going to be about What does the second derivative tell us about stuff? Yes, sir.
I just have a brief thought, is there ever like this kind of stuff with another axis?
Yes. It's called Calc 3. Yeah. Yeah, it is. It's, I don't know, it is what it is. It's not like Calc 1, which is what this is. It's not like Calc 1 is like super easy and then Calc 3 is like way more difficult. It's just like one little more notch up the ladder. I mean, it's maybe a little more difficult, but it's not like this, oh my gosh, I can't do this. If you can do this, you could do that, I would say. Okay, so anyways, get this nice intro video stuff. There was a couple little examples here, and I thought we could jump in here at example 2. Through the intro video, I feel like, oh, my graph is a little bit messed up there. This graph is nice and continuous. It looks like there's a little bit of a little oops in there, right around -1. But let's say this graph is continuous, okay? Forgive my graphic stumble there. So the question is, if you are given the graph of G prime, we're supposed to determine the intervals in which the graph of G is concave down and increasing at the same time, okay? So this is kind of a combination of 3, 3, and 3, 4. It's both. I want you guys to discuss. I want you to try to work through this. It's really simple from a computation standpoint. There are not that many numbers to deal with, right? The concepts are tough. So talk this over and say, hey, Meg, I think it should be this because of that. And Meg's like, that's not what I see at all. I think it's that. Those kinds of conversations, let's have them, all right? Ready?
So when they give you a graph of G prime, can you graph the graph of G prime to make it G double prime?
Oh, you mean graph the derivative of that? You definitely can. Not as easy as it sounds all the time.
Wouldn't they all just be straight lines mostly? Because, or like, I guess there's only two.
That middle section
would not be
probably wouldn't be. The two pieces that are already linear would end up just being constant horizontal lines. Yeah. You can definitely do that. I don't think that that's easiest or fastest, but if that helps you kind of like make some cool connections, go for it. Yes. Definitely do. We another minute or so here.
It's just
Oh no, that's right.
We grab this.
So I have X here.
It's already, it's G prime, so it's 0 points on detail kind of but because
It does appear there's a couple of points where
Oh, you're G double prime.
you could. I don't think you have to at all. Here's something to think about though. Is that graph really continuous?
I'll do this.
If G prime is F prime is
It wasn't even A decreasing. You were just good at English too. I just looked at it. Oh my god, how hard is it?
Okay, let's do this. I think I want to make a point about something here. Like all of those key takeaways that you've seen. Like, let me just show you. So like I'll come back around to this one, but if you guys were to look and see all these key takeaways, like this one right here, these are like the key concepts and skills you got to bring out. If you have stuff like that, if you have that drilled and memorized, and then other stuff, there's others, at the end of like section 3.1, if you have stuff like this drilled and memorized, so on and so forth. What I'm trying to get at is if you have the concepts solid, then you are going to be able to be super duper efficient with questions like this one, because here is what I would suggest maybe we think about. Determine the intervals on which the graph of G is concave down and increasing. I personally look at this and I think you guys are a lot more familiar with looking for where G is increasing because we've done that for longer. So why not discuss that first? See if you can finish my sentence. This would give you great direction. G will be increasing wherever G prime is positive. So on the graph of G prime, what's the only part of the graph that I really want to look at? Above the x-axis. So what I can do then is I can basically take a highlighter, mental or otherwise, and say this up here, that's the only part that I care about. I do not care about any part of G prime being below the x-axis, because if G prime is below the x-axis, G is?
Negative.
G is decreasing. G prime is negative, yes. But yeah, I'm not looking for where G is decreasing. I'm looking for where G is increasing. So I want to look where G prime, the slope of G, right, is positive. So I can ignore the entire bottom half of the graph. Does that make sense? I'm trying to piece this out into pieces I can handle. Now this might be the part that you're not as familiar with. I'm also looking for where G is concave down. So there's two ways to define this, right? So I'll put it over here. G is concave down when number 1, number 2. You said something about G double prime? When G double prime is negative. Agreed. So G is concave down whenever G double prime is negative. But I got to say, that's not a graph of G double prime. That's a graph of G prime. So how could we relate this? We could say G is concave down whenever G prime G is? Say again? Decreasing. So I think in the video I explained a little bit about that. But if you think about it, if G prime is the slope of G and G prime is decreasing, aren't we really saying that the slope of G prime is negative? And what would be another way to name the slope or rate of change of G prime? The derivative of G prime, which is? G double prime. There we go. Let's say that again. If I say that G prime is decreasing, I'm really saying that the slope of G prime, what's the slope of G prime really? Negative. It's negative, but the slope of G prime is really G double prime is negative, which is exactly the same thing we said on number 1. So number 1 and number 2 are saying the exact same thing, just using a different basis for saying it. Does that make sense? Okay, so that if I'm looking for where G prime is decreasing, that would be where I'm highlighting in a lovely blue color. It would be there and there. So wherever the blue and the orange overlap each other, that would be wherever I have a graph of G that is concave down and increasing. So I could mention those intervals and say the interval from -4 to -3 and 1 to 3. G is concave down and increasing. And we'll always do our justifyings in here. So I'm going to put because. How would you guys fill in the because part of this one if we gave a reason? Let's break it into pieces then. Why is G increasing there? Because G prime is positive. I think it is best practice. I really do. I think it's best practice to reason from the information that you're given. G prime is decreasing. So G prime is positive and G prime is decreasing. That defines G being increasing concave down. So I mentioned this at the very start, like back in 3.3 and 3.1. Do you see how this, if you really weren't dedicated to being super sharp with your words, do you see how this gets really confusing? So let's think this over. We did this a second ago, see if we can do it again. If G prime is positive, G is true. If G prime is increasing, then G is concave up. Do you see how this gets tangled? Do you see how if you don't put forth the mental effort, both here in class and on your Web of Science, it'll get super tangled up. And guys, we can keep breaking it down. Basically, think about it like this: as you go from G to G prime to G double prime, aren't you basically saying the slope of G is G prime, and the slope of G prime is G double prime? And so, if you think about it in those terms, you can start to understand. Okay, so that if G double prime is negative, that really means that G prime was decreasing, which means that G is concave down. Make sense? It's not going to, for most people, it's not going to just come to you in like 5 seconds. You will have to put in the time and effort to get there. Okay? For those of us that like to just be real generic and say, well, hey, it's doing this because it's doing that, it's going to be tough. Guys, basically outlined the big challenge of this. It will take some time and effort. It really will. Do you have any questions? Go ahead.
So when it's,
Careful, you just said the word it. Don't say the word it.
when the question says
Okay?
concave up,
Stop. You just said when the question says concave up, I'm going to come back at you and say, what is concave up?
G prime.
G prime is concave up?
Sorry. The graph of G
The graph of G
is concave up. Can it be up and increasing?
G can be concave up and increasing. I'll draw you a graph of G. So if this is a graph of G, concave up and increasing.
Where's my X?
Wherever, it doesn't matter. This, in black, G would be concave down and increasing. Barely at the end. Does that make sense? And then, take it a little bit further. I guess we'll just call this one f of x. This f of x would be decreasing and concave up. F of x would be decreasing and concave down. So let's do this. I didn't plan on this, but let's go here. Again, this is a graph of f. So on this graph right here, f prime is? Oh, no, f is concave down. F prime is? Negative. F is decreasing. And if f is decreasing, f prime would be? Negative. Because f prime is measuring the slope of f, right? You see? We cannot get by with this generic junk of like, it's doing this because it's doing that. We can't be like mentally lazy and just be like, oh, well, it's decreasing because it's negative. What? What does it even mean? Right? It's going to help you be precise in your wording. Okay, so again, on this graph, f prime is negative. F double prime is? F double prime is negative because f is concave down. This is going to be a tough one. Okay, let's back up. So, what do I need to back up to? F, so yeah. F is concave down. And you know how you can tell that? You know what concavity looks like, and you can see the concave part is pointing down. The other parts are harder, right? So F prime is negative and decreasing, right? And F double prime is negative because F is concave down. We can continue to go through all the reasons why. I'll be happy to continue to do that as we go throughout the next days and weeks and whatever. The bottom line is we got to get rock solid. There can't be any questions about this. If you're rock solid, like honestly, if you know all this stuff, your Unit 2 test, for the most part, is going to be insanely easy. But if you look at this and you're like, man, you know what? I never memorized that stuff. It's going to be insanely hard.
So that's just kind
I think you need to know the why. And in the video I explain why, and I'll continue to try to explain the why. But for you to be successful, you just have to know it. And I think knowing the why and memorizing it, I think it's two sides of the same coin. If you don't memorize it, then knowing the why is kind of pointless. And if you don't know the why, then memorizing is kind of pointless as well. You got to have both. Meg, your question? F prime could be what? I never said F prime is decreasing. I never said that. I said F prime is negative. I wrote it right. Did I say it wrong? F double prime is negative on this. Because F is concave down.
I'm confused. I thought F prime could be
You have to talk a little louder. You said, I thought F prime couldn't be decreasing?
Yeah.
It is. Check this out. Remember, F prime is the slope of F, right? Guys, this will probably be super useful for you. Pay attention. F prime is slope of F? I just need rough numbers here, just estimates. Don't try to be perfect. What would you say right here the slope is? Just give me something. It'd have to be negative, wouldn't it? Okay, so slope is -1. What's the slope? I'll just use M for slope. What's the slope right there? Fair enough. What's the slope right there? A much more negative number, right? Again, Meg, I'm not looking for perfect numbers. Right there, slope is -15. I want you to think about this. I go from left to right. Do you see how my slope went from -1 to -3 to -6 to -15? If that's not a decreasing pattern, I don't know what is. See what I'm saying? Like literally the numbers for slope go from a -1 to a -3 to a -6 to a -15. Isn't that a pattern of decrease? Yes? Let me show you. So since F prime is decreasing, that means the slope of F is negative, which means that F double prime is negative. Because F double prime is simply the slope of F prime. Come over here, check this one out. What if I did, I'll just erase this one just for clarity's sake. Clearly G is concave up, right? Okay, so I'll say right here, what would you say the slope of G is? Can I just say 0? Okay, I'll say 0. Okay, how about right here? What's the slope of G right there? 1. Okay, how about right here? And up here? Okay, so the slope of G went from 0 to 1 to 3 to 7. What kind of a pattern is that? So in other words, the slope of G, also known as G prime, was increasing. And can you connect that with the pretty clear visual fact that G is concave up? Make sense? So again, as I go from G to G prime to G double prime, I'm just saying the slope of G is G prime. The slope of G prime is G double prime. Okay? How are we doing? You guys are so awesome. Like when I told you this would get tangled up like a week ago, you're like, yeah. You get it now, don't you? You got to know what you're talking about. And you can do it. You're rookies right now, but give yourselves a little time. You'll get good at it.
And what about the other side of that on your drawing? The one that's going down, but it's
So this is a totally different graph.
yeah.
What about it?
Like, can you do the same checklist for that one?
Sure. Okay, guys, check this out. So for this curve right here, this is F over here. So we would say that I'll say F is decreasing and concave up, right? F is decreasing and concave up. And you can just see that because I gave you a graph of F, and it's like, it's right there. You know what decreasing looks like, you know what concavity looks like, there it is. F prime, so if F is decreasing, F prime is negative. And if F is concave up, F prime is increasing. Therefore, F double prime is positive. Let's go through and let's look at the values of F prime, or at least our estimates. So let's see here. This one's a little bit tougher. So slope of F right there, just give me a random estimate. It'd have to be, no, it'd have to be negative. Wouldn't it have to be negative?
Negative 15.
I'll go with negative 7. So negative 15 would be just as good. Okay, so if that's a slope of negative 7, what's the slope like right about there? Okay, what's the slope right about there? And the slope right here would be like negative 1/2, let's say. This is tougher, but if the slopes, you can always judge from left to right, if the slopes of f are going from negative 7 to negative 4 to negative 1 to negative 1/2, is that not an increasing pattern? All the numbers are negative, I get it, but negative 7 is less than negative 4, which is less than negative 1, which is less than negative 1/2. So we're getting bigger and bigger as we go from left to right on the slopes. And so for that reason, f prime is definitely negative. You can see all the negative values of f prime, right? All those numbers are negative. You guys are correct. But can you see how f prime is increasing as well? And if f prime is increasing, that means the slope of f prime is positive, which means f double prime is positive, which means f is concave up.
Can you do that one more time?
Do what one more time?
That what you just said.
Sure. So you can clearly see that f prime is all negative on this, right? Because we estimated our slopes reasonably, right? So if f prime is negative, then f is decreasing. But you can see that we have clearly an increasing pattern in the slopes of f, right? Negative 7 to negative 4. Negative 4 is bigger than negative 7. And negative 1 is bigger than negative 4. And negative 1/2 is bigger than negative 1. So the slopes of f, aka f prime, they're increasing. Okay, so if the slopes of f are increasing, the slope is, so the slope of f is f prime. Right, so if the slope of f prime,
It's going up to 0.
yeah, it's going up to 0, from negatives up to 0.
It's almost going to 0.
So if f prime is increasing, that means the slope of f prime, also known as f double prime, would have to be positive. Therefore, f is concave up.
But the last one, it was like this down. It was concave down.
Yep.
It
So the
was-
slopes of f were decreasing. Oh, I guess I erased it.
Okay, decreasing. So then f prime is negative decreasing in f double prime.
Yeah, and f is concave down because of that. True. It's pretty abstract. I know it's not easy. Let's see here. Let me just look. I know we're short on time. Let me just see what we got here. Points of inflection. Oops. There we go. Okay. Yeah, we'll do our best on Monday or Tuesday, I guess, for you guys. See how it goes. So listen, I think you guys can probably tell, like the last 15 minutes were just like off the cuff, like unplanned, and I'm okay with that because I feel like I'm hoping that the time I invested in you guys here will pay off later when I say, hey, f double prime's positive. You won't be like, do you see what I'm saying? So if f double prime is positive, f is concave up. There you go. So we need to be super good at that. If you feel the need to make some flashcards, I would. Have a great day. Have a great weekend. See you guys.
Positive is positive.